Hello and welcome back to the channel. My name is Shiki and today we're continuing our Kubernetes series by starting to discuss about different types of objects in the Kubernetes ecosystem, beginning with obviously pods. That's because last time we've discussed about how to deploy an item to Kubernetes, and before that we talked about architecture, so I feel we're ready now to start discussing the full potential of Kubernetes, beginning with analyzing its resources. So today we're going to find out exactly that. Let's jump right in. What is a pod? A pod is a Kubernetes construct which behaves like a host for one or multiple containers. So if we're imagining this cyan box as being a pod, inside of it we might find one or more containers. And by containers, I mean Docker containers or any other type of containers. Yeah, so CNI compatible images that run. Okay? And the caveat that you need to know about here is that this pod, when it is created, gets assigned one IP address. So it actually behaves like a host in which multiple containers can run. And if you want to expose any of these containers to the outside world of the pod, you need to map the container to a port, like we were doing initially locally in the Path to DevOps series, if you've been following that as well. Yeah. So if you have multiple containers in one pod, you need to map each container to a different port. And more than that, containers sitting in the same pod can access one another using localhost. So it basically behaves like a host. Okay? One more thing to notice here is that if you delete the pod and recreate it identically, so you create an identical pod with the same number of containers, same images for those containers, you're not insured to receive the same IP address. So this is very important moving forward. Yeah, the pod does not or may not receive the same IP address if it gets deleted and recreated, or if it fails and it gets recreated. Okay, keep that in mind. Another thing I would like to add, which pertains to Kubernetes networking, is that you can find out on which node a pod sits on by looking at the third octet in its IP address. So let's say a pod sits on node 1 and another pod sits on node 2 in a multi-node cluster. They will have a different number here in this octet. So you can check which pods are neighbors on the same node by looking at this octet right here. Okay, so keep that in mind. It might be useful when troubleshooting. Having said this, let's talk about the types of containers you can encounter inside of a pod. And it's actually 3 of them. We're going to start in the order they're actually getting processed or created. So these are the 3 categories. The first one is init containers. Then you have the actual application containers, and there's something called ephemeral containers. When we talk about init containers, it's actually the containers that get evaluated first and are used for preparing stuff necessary before the application actually gets started. So maybe initializing a database or preparing a volume with some data so that when the application starts, it can actually grab that data from the volume. And this type of container, the init container, must run to completion. Okay, and the exit signal must be a successful one, okay, for the process to continue. After all of the init containers have been processed, then the app containers get started. And this is exactly where you want to be hosting your workload, inside of an app container. These are, as I said, evaluated after the init containers are all completed successfully. And you can run long-lasting processes inside of the app containers, which means you can run something like an Nginx server or any other type of web server or a Java process with a listener, stuff like that. Basically, your application, your workload. And the third type of containers you may encounter inside of a pod are ephemeral containers, and they are mostly used for troubleshooting. Okay, you should not run your workload here. It's basically a container which attaches inside of a pod, and you can run stuff from there. I'll give you an example. Let's say you want to have an app container with an Nginx server, but you don't want to put a lot of tools in that image so that if a hacker gets access to that, it won't get tools to break the environment. So you will actually attach a different ephemeral container to the pod, and that ephemeral container will contain the troubleshooting and debugging tools that you need. Stuff like PS, NS lookup, curl, and all that jazz. So you can do your troubleshooting and then you can stop that container and you're good to go. Because we introduced all of these new terms, the best way to let them sink in is to go to a demo and see everything in action. About the demo, we're going to use a pre-existing YAML file and deploy that into my Rancher desktop Kubernetes cluster. I won't be using anything external. So yeah, if you've installed Rancher desktop so far, you can use the Kubernetes cluster that comes with it. If not, I'm going to leave a link in the description for you to download the tool. It's pretty useful. It's like a local Kubernetes environment where you can test stuff. So looking at the screen, you can see that a pod actually has 4 required parameters in its YAML template, and the first one is the API version. This is version 1, and as it says here, it defines the schema of the object you're trying to deploy. Version 1 is fine for us. And then you need to specify the kind of resource you're trying to deploy, because today we're talking about pods. It's a pod we're trying to deploy. And then we have metadata, which is basically key value pairs or lists of key value pairs that identify our pod. So the name of our pod is going to be Nginx, and also I'm adding some labels. I'm saying the app is Nginx and owner myself. Yeah. And the fourth parameter that you need to add here in the pod, or the fourth YAML object, whatever you want to call it, is spec. And this is where the magic happens. It's the specification of your containers. And as you can see here, we also have both init containers and containers. But also some other objects that I want to go through right now. So first, image pool secrets. This is very important, and it cost me a lot of time when I was learning Kubernetes back in the day. If you want to pull an image from a private image registry or container registry, you need something like this. Yeah, it will be a Kubernetes secret, which contains some data about authenticating and authorizing the request to pull that container from the private registry. Yeah, and then you specify the name of the secret here. Okay, I don't have any, so I just put it here to talk about it a bit. Then you have the restart policy of the pod, which means what happens if your pod fails. Should Kubernetes try to bring it up and try again? Or in my case, the restart policy is never, which says basically I don't care. Yeah, once this dies, nothing else will happen. But basically you have always, which means if your pod fails, it will always try to bring it up. On failure, so only if the pod is in a failed status, it will try again. And never, in my case, if this fails, nothing will be restarted. Moving forward, we have, as we spoke earlier, init containers. So this container inside of the pod called Nginx, I will have one container called init namespace. And what this guy does, it will start this image right here, and it will run a simple command. What this command does is an if, and if the name of my namespace is Shiki, then it will echo we are in the right namespace. Otherwise, it will say this is not the right namespace, and it will sleep for 1 hour. Okay? That's basically it. So basically this application will only run successfully immediately if I'm deploying in the Shiki namespace. Otherwise, it's going to just sleep in the init container for 1 hour without actually starting my app container. So if we're talking app containers, this is it inside of the containers object, and it will be a container called Nginx. The image will be the latest one from Nginx, and the container port is port 80. All right. So basically, if I'm deploying this into the design namespace, which is the Shiki namespace, it will start my Nginx container. If I'm deploying it in any other namespace, it will hang or it will sleep for 1 hour in the init container, and it won't actually get to the point to deploy my Nginx server immediately. It will do that after 1 hour. So let's test this theory. I will open a terminal and close the old one. Yeah. kubectl create namespace Shiki. Okay. This is the first thing we need to do. And it says, yeah, you already have a Shiki namespace, which is great. We're going to use that. But first, let's deploy. So just kubectl. I'm going to maximize this so you can see the full object. All right. As you can see here in the metadata object, I didn't specify any namespaces. So if I do kubectl apply -f and I try to apply this pod.yaml, it will actually deploy it to the default namespace, yeah, because I haven't specified any namespace in the YAML nor in the command. So let's do that, and it says here pod nginx got created. So if we do kubectl get pod, you will see it's running for 9 seconds inside of the init container, the first init container. If we do it again, it's still at the init container, so something went wrong. And what we can do to figure that out is kubectl logs nginx is the name of the pod, and you need to also give it -c for container, and the name of our init container is init minus namespace. And lo and behold, it will tell us that this is not the right namespace, so basically it's sleeping inside of the init container. I will never get to run my nginx server in this hour at least. So what I'm going to do is kubectl delete and delete the YAML file. And once I've done that, I will also apply the same file again, but now in the Shiki namespace. And this time pod nginx got created again. Get pod namespace Shiki, yeah. And now you can see the status is different, yeah. Ready 1 out of 1, status is running, so we're no longer locked on the init container. And if we run the same command of kubectl logs on the container, but this time we add the namespace Shiki in the command, we will see that it told us we are in the right namespace, which caused the init container to close and to proceed to the actual app container and start our nginx server. But what if I wanted to debug my nginx server that just started? Well, now we're going to use the third type of container we haven't discussed about yet, and that's the ephemeral container. So what I'm doing now is running the kubectl debug command, and I'm going to run it in an interactive mode, and the name of the pod is nginx, yeah. And what I want to do is I will use a container image called busybox 128. It's actually the same image in my init container by chance. And I'm going to attach this to the same pod and to the nginx container inside of that pod, yeah. So it says here targeting container nginx, yeah, as I specified. And now I'm inside of some kind of terminal. So if I do ls, you will see that I get a Unix file system. If I do ps-a, you will see that nginx processes are running, yeah. So that's basically telling me that now I'm inside, I'm attached to the container that's actually running the nginx server, which is basically my app container. So I'm actually attached to this container using an ephemeral container, okay. And the way we can see that even better is if I open a different terminal, and now we do kubectl describe pod namespace Shiki. And once I do this, we will see now that I have init containers, yeah, I have containers, but now I also have ephemeral containers, which have a weird name, debugger something, but I started that from a command line instruction, yeah. So that's basically how you use an ephemeral container for debugging. One more thing I would like to point out before ending this episode is that we have an IP address somewhere here, and there we have it, yeah, 10.42.0.19. Let's just save it in here. Let's open Notepad and save it. Remember, 10.42.0.19, that's our IP address for the pod. And what I want to do now is I want to exit this, and I will delete the pod one more time. And I will create the pod one more time. And now let's check the IP address one more time. And now you can see it's a different IP address because initially we had 1042.0.19, and now we have 1042.0.20. So basically, you cannot ensure you receive the same IP address after deleting and recreating a pod. And then my question for you guys is, how can you make sure you send traffic to a pod if its IP address is ephemeral? Yeah, it's something that gets allocated dynamically. And we're going to talk about the solution to this question in the next episode when we talk about services. So, thanks a lot for your time, guys, and I really appreciate it if you could hit the like and subscribe buttons, and I'll see you next time. Thanks a lot. Cheers.